Question 4, we want to write quadratic equation with the given solutions. So let's see A. So two solutions, which means we can write it as x equals to 3 and x equals to -1. And we rewrite this as x minus 3 equals to 0. For this one, x plus 1 equals to 0. But we multiply those two. X minus 3, x plus 1 equals to 0. And maybe you can FOIL out x times x squared. -3 times positive 1, -3. -3 times x, -3x, x times 1, 1x, and -2x equals to 0. So this is the original equation, right? Previously, from 1 to 3, we did this way. We were given the equation, we solve for the solution. Right, we're given this equation, we put it in a factored form, or we do use other formats. Then once we have factor product of two factors to be 0, we use 0 property, split them, you get two solutions. Now we're doing reverse. Right? We're given those two solutions, we're doing the reverse way to find the original equations. Well, let's see B. B means we have x equals to half, x equals to 4. And we can write this as x minus a half equals to 0. X minus 4 equals to 0. Then x minus a half, we can multiply by 2 on both sides. So we can write as 2x minus 1 equals to 0. And x minus 4 equals 0. Now we multiply those two by 2x minus 1 is 0. X minus 4 can be 0. Multiply 0 times 0 can be 0 also. Simplify, we have 2x times x, that's 2x squared. -1 times -4, positive 4, right, equals 0. So we need to figure out the middle term. The middle term will have -1x, -8x, that's -9x. So the original equation for B is 2x squared minus 9x plus 4 equals 0. Now let's see C. C will have two complex solutions, but we do the same thing. X equals to 2i, x equals to -2i. That's x minus 2i times x plus 2i equals to 0. Or that's x squared plus 4 is 0, right? Sum of two squares we can factor as two complex numbers. Well, we can check x times x, x squared, -2i times 2i, -2i times 2i, we get -4i squared, but I squared is -1. So we have -4 times -1, that becomes positive 4. So that's our original equation. So in real number world, we have difference of two squares, but in complex number world, we have sum of two squares can be factored. Let's say D will have two irrational solutions. But we're going to do the same thing. That means that we have x minus, we can write it out, x equals to 2, radical 3, x equals to 2 minus radical 3, right? That means we have x minus 2 minus radical 3 times x plus 2 minus is this one, right? Then -2 minus a negative, that's plus. So we have x minus 1, x plus 1. Or even easier, you have these two solutions, x1, x2, right? Which means x1 times x2 give us the constant term. So let's multiply those two. Multiply those two, the difference of two squares. We have 2 squared, which is 4, minus 3, which is 1. And add those two. So x1 plus x2. We can use this for the previous ones too. x1 plus x2 That's 2 plus 2, which is a 4. And positive radical 3 minus radical 3, that becomes 0. So we know we have x squared minus, so this is positive 4 plus 4x. This is positive 1 plus 1 equals to 0. Right? Because when we have two solutions, the constant term is multiplying the two solutions. The coefficient of the middle term is add those two. So we could check this with C. So C, another way we're doing C is we multiply those two solutions, so 2i times a negative 2i. Negative 2i. We get a positive 4. Right? 2i plus negative 2i. We get 0. So that means the coefficient of x is 0 and the constant term is 4. So right away you can write it as x squared plus 4 equals 0 also. So this is another way of doing that. But preferably in the beginning, you're doing this way, okay? You do this way, because this way is more logic. But once you get good at this, then you can do that, you see. Okay, x1, let's do 8. x1, you can write as x1. x1 equals 3, x2 equals to negative 1. And you know in the standard form, ax squared plus bx plus c equals to 0. We can always divide by 8, right? So let's ignore this 8. Let's make it 1x squared. So when the coefficient of x squared is 1, then b equals to x1 plus x2. And c equals to x1 multiplied by x2. So in this case, b equals to 3 plus negative 1, which is 2. And c is 3 times negative 1, which is negative 3. So you see from here, also we can write it as x squared minus 2x minus 3. Hold on a second, y minus 2x, x minus 3. Yes. Here we have 3 plus b equals to 3 plus negative 2, negative 1, right, negative. So, or we can think of this as a negative b, okay, negative b. So then b equals to negative 2. So we can write as x squared minus 2x minus 3 equals 0. All right. So this, in this case, so this is a minus 4x. All right, minus 4x. So this is better. So this way, this method is better for irrational solutions. Otherwise, we can go through the normal procedure. Let's try that. Let's go more logical way for D. Right. So D, we can write as x equals to 2 plus radical 3. X equals to 2 minus radical 3. So those two, this one we can write as x minus 2 minus radical 3. Then multiply by x minus 2 minus radical 3 becomes plus radical 3. Then equals to 0. Then we can do this, right? We can, so we can treat this one as one term, this one as one term. So we x times x squared, first term. Then this one times this one will give us constant. So 2 plus radical 3 times 2 minus radical 3 is 2 conjugates of difference of 2 squares, which is 4, 2 squared minus square root 3 squared, which is 4 minus 3, which is 1. So we have plus 1. And the middle term, we see we have this one multiplied by x plus this one multiplied by this. So that's why the middle term, the term before x, we just add those two. So we have 2 plus radical 3 plus 2 minus radical 3. Then we put a negative sign in front. So 2 plus 2, that's 4. Radical 3 minus radical 3, that's 0. So we got negative 4. So we got minus 4x. Okay, now let's see 5. 5, we want to graph quadratic equations, quadratic functions, and identify vertex intercepts. Intercept means x-intercepts and y-intercepts, and the axis of symmetry. So remember, when we write a function in the form of a times x minus h squared plus k form, then the vertex is h comma k, right? But be careful, this is x minus h, and here is plus k, okay? So in this case, we see a is 2, h is 4, k is -3. So we see the vertex is 4 comma -3, because in the formula is a plus k, so plus -3. Well, intercepts, let's do maybe x-intercepts. Let's review the definition of intercepts. X-intercepts means the y value is 0, right? Y-intercepts means the x value is 0. So x-intercepts means y value is 0. So that means f of x is 0. So have 0 equals to this. Let's write here. So to have 2x minus 4 squared minus 3 equals 0. Basically, the function value is 0. Then we move 3 to the other side, becomes plus 3 on this side. Then we divide by 3 on both sides. So get 3 over 2. 0 plus 3 is 3. Divided by 2 on both sides. So we get x minus 4 squared equals to 3 over 2. Now we use the square root property. So plus minus square root on both sides. So we have x minus 4 equals to plus minus square root of 3 divided by square root of 2. Now -4 we move to the other side, become positive. So we get two solutions. Right, we get two x-intercepts. So one is 4 plus radical 3 over radical 2. Well, maybe we want to rationalize this number. And this becomes 4 plus minus square root of 6 divided by 2. Now the denominator is rationalized. So I have two x-intercepts. One is 4 plus radical 6 divided by 2, comma 0. Another one is 4 minus radical 6 divided by 2, comma 0. We can keep as irrational form. Right? In this case, it's the exact value. We don't have to approximate. Now let's find the y-intercept. The y-intercept means x value is 0. So we just need to find f of 0. X value is 0. So 2 times 0 minus 4 squared minus 3. Well, 0 minus 4 is just minus 4. Minus 4 squared is 16. So 2 times 16 minus 3. 2 times 16, 32. 32 minus 3, 29. So the y-intercept is only 1, 0, comma, 29. And x-intercept, we have these two. Right? We have these two walk back. The y value is 0. So axis of symmetry, once we have a vertex, the x value is the axis of symmetry. So axis of symmetry, we write as x equals to 4. Now let's try the graph. Right. So y-intercept is 0, comma 29. So let's see, this is 29. So we have this y-intercept. And the vertex is 4, comma -3. Well, this is 29, almost 30. That means this is about 10, right? So -3 is somewhere here. Right, so this much will be -10. 4, let's see 4, maybe 4 is here. 4, 8. The increment on x-axis and on y-axis doesn't have to be the same. So let's see 4, comma -3, somewhere here. So the vertex is here, and the y-intercept is here. X-intercept, well, how do we find the x-intercept? But we know this, because this is the vertex, so the line of symmetry is right here. So x equals 4 is a line of symmetry. And we have this y-intercept right here, so we can graph. Remember, quadratic is like roundish, right? round, curvy, roundish. And the 4 plus radical 6 over 2. Let's think about this value. When you graph, maybe you can press into calculator. Or let's just think, what is this value? Radical 6 is in between of radical 4 and radical 9. Right? Basically 2 and 3, between those two values. Then we divide by 2. So when we divide by 2, we divide by 2, we divide everything by 2. So this means it's in between 1 and 1.5. Now let's add 4. So if we add 4 plus 4 in the middle, that means we plus 4 here or plus 4 here. You see the number is in between 5 and 5.5. Right? So we could mark the plus one. So this one is like a 5.5, but we could just write a 4 plus radical 6 divided by 2 comma 0 here to indicate this point. And the other point on the other side is read as 4 minus radical 6 divided by 2 comma 0. To x-intercept. Okay, so that's what we do, right? Because this is in the index form. So we use the standard form h comma k to identify the vertex. In this case, the vertex is 4 comma negative 3. And once we have vertex, we know the x value is the line of symmetry or the axis of symmetry. X equals, we write as x equals 4. Then we need to find the x-intercepts. X-intercept, we set the y value to be 0, the function value to be 0. Then we solve for x. In this case, we have two irrational numbers. And then for y-intercept, we set the x value to be 0. Then we evaluate f of 0. Okay, let's do the same thing for b. So b, let's figure out the vertex first. Vertex h comma k, x minus h. So this is minus 3. So the x value is negative 3. And the y value is 1. Because h, x minus h plus k. Once we have vertex, we know the axis of symmetry or the line of symmetry. The line of symmetry. It's just the x value. X, we write out the equation x equals to negative 3. Then let's figure out the x-intercept. X-intercept will set the function value to be 0. So that means 0 equals to negative x plus 3 squared plus 1. We'll move 1 to the other side, becomes negative. Right? Just negative 1. For negative 1 negative, so multiply negative sign, negative 1 on both sides. We get 1 equals to x plus 3 squared. Now we square root both sides. Square root both sides, so we get x plus 3 equals to square root 1, just 1, plus minus 1. So get x equals to negative 3. So we move 3 to the other side, becomes minus 3. 1 minus 3, negative 2. Negative 1 minus 3, negative 4. So get two values. Get 2, so get negative 2, comma 0, and negative 4, comma 0. Now let's check y-intercept. Y-intercept means x value is 0. We need to solve for the function value f of 0. Well, that's a negative 0 plus 3 is 3. 3 squared plus 1. Well, negative 9 plus 1. Negative 8. So the y-intercept is negative 0, comma negative 8. Now we can graph with all this information. Let's graph vertex first. Negative 3, comma 1. Let's see, this is a 1. Negative 1, negative 2, negative 3, negative 3, comma 1. Let's see, this is a 1, 2. So vertex is here, right? Negative 3, comma 1 is a vertex. Then we have negative 2, comma 0, and negative 4, comma 0. Well, this is negative 2, comma 0, negative 4, comma 0, somewhere here. So a line of symmetry is x equals to negative 3. And the y-intercept is 0, comma, -8. 0, comma, so the 2, let's see, this is 2, 4, 6, 8. Somewhere here. 0, comma, -8. That's our y-intercept. And you see the A, the leading coefficient is negative, so we have downward parabola. So this is the vertex going through the x-intercept. This is the vertex going through the x-intercept and also go through the y-intercept, right? The y-intercept. That's the graph. Now let's see C. C will have upward parabola because the leading coefficient 3 is positive. So the vertex x minus h, so the vertex is -1, comma, -2, because it's plus k. Then the line of symmetry is x equals to -1, x value. X-intercept, we set function value to be 0, so we have 0 equals to 3 times x plus 1 squared minus 2. We'll move -2 to the other side, becomes 0 plus 2, which is 2, divided by 3 on both sides. Then square root both sides. So we get the x plus 1 equals to positive and negative square root 2 over square root of 3. And we may rationalize this number by multiplying square root 3 divides itself. So that becomes plus minus square root of 6 over 3. Now minus 1 on both sides, so -1 plus minus root 6 over 3. So I have two x-intercepts, the y-intercept. We want to evaluate f of 0. F of 0 is 3 times 1 squared, which is just 1. So 3 minus 2, which is just 1. So the y-intercept is 0, comma 1. Now we can graph. So vertex is -1, -2. So let's see, this is -1. This is -2. So vertex is here. And we have upward parabola because A is positive, is 3. And we have these two irrational. So let's draw the line of symmetry first. And let's graph the y-intercept first. This is 0, comma 1 is the y-intercept. So this is, so we have a vertex here, and we have a y-intercept here. So just go up, graph this way. And this is line for symmetry, so the left-hand side has to be the same. Then we just mark these 2 points. And this point will be -1 minus radical 6 over 3, comma 0. And this point we mark as -1 plus radical 6 over 3, comma 0. Okay, that's C. Now let's see D. D looks a little bit different, right? But we have downward parabola. And now we have x squared plus 5. How do we figure out the vertex here? If we want to put it in the vertex form, so we have negative x minus 0 squared plus 5. Okay, so vertex is 0, comma 5. And then our line of symmetry, just x equals 0. What's x equals 0? Y-axis. And then let's see x-intercept. X-intercept means the function value to be 0. Negative x squared plus 5. Move negative x squared to the other side. 0 plus x, so we'll get x squared plus 5 equals to 5. Then we square root both sides, so that x equals plus minus square root 5. So we have 2 x-intercepts, positive radical 5, 0, and negative radical 5, 0. Now y-intercept, we evaluate x value to be 0, f of 0. Well, x 0 squared is negative, so just a 5, right? So 0, comma 5, let's see, this is 1, 2, 3, 4, 5. So this is our vertex. Our vertex is on y-axis. The vertex could be on y-axis, could be, if it's on y-axis, it's the same as the y-intercept. You see vertex and the y-intercept are equal to each other. So those 2 points is the same point. Sometimes maybe the vertex is the x-intercept to have some special situations. So in this case, we have 0, 5 as our vertex and the y-intercept. And then the line of symmetry is just this y-axis, or x equals 0 is our line of symmetry. So x-intercept, square root 5, is in between 2 and 3, right? So we just mark this -1, -2, this as 1, this as 2. And -3 and +3, because square root 5 is just a little bit bigger than square root 4, so a little bit bigger than 2 and -2. So that means that here we have somewhere x-intercept here, a little bit, but negative square root 5, a little bit less than -2. So we graph, we have a downward parabola, right? Because it's a negative, the leading coefficient is negative, we have downward parabola. And that's it, that's the graph. Now let's see 6. We also want to identify vertex, intercepts, and the line of symmetry. And then we have standard form here. Remember, this is ax squared plus bx plus c. In this case, so the line of symmetry, x equals to -b over 2a. So in this case, it's a negative, or b is -4. So -4 divided by 2 times a, or a is -1. So we have 3 negative signs, negative, 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 3 negative signs result in -4 divided by 2, just 2. So the line of symmetry is -2. For the vertex, the vertex value, x value is -2, same as the line of symmetry. Then we have to evaluate f of -2, the y value, function value. We get -2 squared -4 times -2 and -8. -2 squared, -4. Right? -2 squared, +4, but we have negative sign up front. -4 times -2, +8, then -8. Well, those two can sort of be zeros, get a -4. So -2, -4 is our vertex. And the x-intercept, we set the function value to be 0. So we have -x squared -4x -8. Well, multiply by -1 on both sides. So get x squared plus 4x plus 8 equals to 0. Now we need to solve for x. We could use the completing square method, right? That's x squared plus 4x plus 4 plus 4, because we change a to be 4 and 4. And this gives us a perfect square. That's x plus 2 squared equals to move 4 to the other side, becomes a -4. Square root both sides, we get x plus 2 equals to plus minus square root of a negative number. We get a complex number. So that's 2i. So we get a 2 complex solution. -2 plus minus 2i. Now y-intercept. Let's do y-intercept here. Y-intercept, x value is 0. We want to evaluate f of 0. Well, that's just -8, right? When x is 0. So y-intercept is 0, comma, -8. Now let's graph. So -8, maybe we let this be -4. So somewhere here, -8. So this is our y-intercept, 0, comma, -8. Then we see we have downward parabola. Let's graph our vertex. Our vertex is -2, -4. So let's see -2, -4. So let's see this is -1, this is -2, -2, -4. So this is -2 in here. Then this is our line of symmetry. So line of symmetry is x equals to -2. Then we have this y-intercept. So the graph goes this way, cross this. Then it has to be symmetric the other side. So that's our graph. You see, how do we graph our x-intercept? There's no way to graph our x-intercept because we have complex numbers, right? And these lines are real numbers. When we have complex solutions, x-intercepts, that means our graph goes away from x-axis. We never touch or cross x-axis. Okay, now let's see B. B, so x equals to negative b over 2a, which in this case, b is 2, negative 2 over 2 times 1, so negative 1. Then we need to find f of negative 1. Negative 1 squared plus 2 times negative 1 minus 4. Negative 1 squared is 1. 2 times negative 1, negative 2, negative 4, negative 5. So our vertex is negative 1, negative 5. X-intercept. Set the function value to be 0. So we have x squared plus 2x. Well, we have minus 4. We can write as plus 1 minus 5. Plus 1 minus 5. Because this gives us a perfect square. X plus 1 squared. Right? Then we move negative 5 to the other side, become positive 5. So equals to 5. Then we square root both sides. Plus or minus square root 5. So get x plus 1 equals to plus minus square root of 5. So x equals to negative 1 plus minus square root of 5. So we have two irrational x-intercepts. Let's see y-intercept. X value is 0. We want to find f of 0, well, which is negative 4. Right. All right, now we can graph. Graph our vertex first. Negative 1, negative 5. Let's see this. Negative 1, 2, negative 1, negative 5. Maybe this is, maybe, let's see. 1, 2, 3, 4, 5. Okay, I'd like the negative 5 to be here. So this is our vertex, negative 1, comma, negative 5. Then our y-intercept is 0, comma, negative 4. 0, comma, negative 4 right here. Right, and our line of symmetry is x equals to 1. And with this, we can graph. Oh, we need to graph x-intercept. X-intercept of negative 1 plus radical 5, negative 1 minus radical 5. Right, these two numbers in between negative 1 plus radical 4, and negative 1 plus radical 9. Right, negative 1 plus radical 4 is 2, which means 1. And negative 1 plus 3, which is 2. So in between 1 and 2. So this is 1, and this is 2. And closer to which side? We say square root 5 is closer to square root 4. So we mark some point here. So then this is a vertex going through the y-intercept, going through the x-intercept upwards, right? Because the leading coefficient is positive 1, upward parabola. So by the line of symmetry, so this is negative 1, negative 1, negative 2. So this is negative 2 is 2 point something, 1, 2, negative 3. So we'll get another by symmetry, right? By symmetry, we have another, which is a negative 1 minus radical 5. Well, this is in between of, this is bigger than, because it's a negative radical 5, right? We split, we switch negative radical 5 is bigger than negative 3, but smaller than negative 2, right? Then minus 1, minus 1. So this means minus 4. This means minus 3. So it's been in between negative 3 and negative 4. You see right here, right? But closer to negative 3. So now we can graph. Okay, that's the graph of B. Okay, so this slide is for 4, 5, 6 is graphing quadratic functions.